So anytime a problem asks you if something is on the interval blah blah blah, it's referring to the intervals, the x values. So if I'm saying, is there a local min on the interval of 0 to 3, it's asking from 0 to 3, oh, that doesn't show up very well. From 0 to 3, is there a local minimum? Is that frozen? It's frozen. Well, all right. So from 0 to 3, if I am looking at my graph, is there a local minimum from 0 to 3? No. There is a what? What is that point way up there? Yes, it is a local maximum. Local max. What is going on? So here I would write that this is false. There isn't a local minimum, there's a local maximum. So the second one says there's a local max on the interval 0 to 3. So from 0 to 3, if I follow the line of my equation, the line of my function, is there a local max? Yes, there is, right? Way up here. Right up here. There is a local max. Do you see it? What is going on? Oh my God. There we go. Way up there. If I follow the line of my graph from 1 to 3 on the x-axis, there is a local maximum. So is that one, number 2, true or false? It is true. There is a local maximum. So now we're looking at a different interval from -2 to 0. Where is that on my graph? Oh my God. What do I look at? From what to what? Look what I made.
Oh my.
Because of moments like this. Austin H. So if the problem asks, there is a local min on the interval -2 to 0 on our graph, where are we looking?
A local min?
Where are we looking? Okay. What interval, what space of the graph am I looking at? If I'm going from -2 to 0.
Left 2?
Right. I start left 2 and I go to where? 0. I follow the line of the graph there. Is there a local min on that portion of the graph?
Yes.
Yes. Where is it? Beautiful. Right here is a local min. So was there a local min on the interval -2 to 0? Yes. So what do I put there? True. Wonderful. There is only one root, Jason. Is there only one root?
No.
Why not? Okay, Philip, why is there only one root? Why is there not only one root? How many are there? There are 3. Where are they? You guys are being with. What is big? On this graph, what is on our roots?
Dots.
What dots are what color are those dots?
Red.
Ah, the roots are the big red dots. The roots are the big red dots. You were being way more specific than I wanted. So here, there's only one root. What do I put? False. The function's range values are all positive on the interval negative infinity to 2. So here, I'm looking to the left of my graph or the right of my graph, Serena? To the left, good. Are all of my range values positive there, Peyton? No. Oh, wait. So going from negative infinity, which is way, way, way down the x-axis that way, all the way up to negative 2, my range values, range is what values? Y. My y values, are they all positive? Your y values. So, here is my graph, right? It keeps going up like this. I'm asking if I'm reading my graph from negative infinity up to 2, are all of these values positive for my y? Yes. So here, what would I put?
Wait, but doesn't it go?
But I'm stopping at negative 2. I'm stopping. It's true. Because the interval stops at negative 2. So I'm stopping here.
Yeah.
If I didn't stop there, you're right. It does go down into the what? Negative.
Yeah.
So these aren't positive.
Okay.
Okay? So this is true. Whew. Okay. So now, any more questions on intervals on a graph?
Are intervals listed with like the square brackets, or is that just because?
So this just meant it's including the value of negative 2.
So how do you know whenever it's talking about like a set of points and not like a?
It'll say on the interval.
Okay.
Interval. It'll say this is an interval. Because you're right, sometimes intervals look like points.
Right.
Mm-hmm. You're right, they probably should have sorted that out.
That's where I got. That's why we were confused.
Oh, okay. On the interval, clues you in that this is interval notation. Just like you use for domain and range, and just like we just used in inequalities.
Because I thought that was asking like the points.
Oh, no. Oh, I see. Okay. All right. So now, this problem right here is going to keep popping up until everyone in here knows how to do it. I'm asked to expand and simplify. What should I do first here? Joseph. You expand out the x minus 4, yes. So this becomes 1/2 x minus 4 times x minus 4. Don't forget to bring down the plus 7. What should I do next, Morgan?
After that, you should put in quotes that you multiply the x.
Good. What method would you like me to do here? Box or double distribute?
Double distribute.
Okay, good. That's what I like too. Thank you. So, what do I multiply first, Sydney? If I'm double distributing these parentheses, what do I multiply first? The x's. X times x, x squared. What do I multiply next, Daniel? Good. X times negative 4. And what do I get? What do I multiply next, Robert? Right. Again, this negative 4 times x. And then lastly, what do I multiply, Ella?
You multiply the last.
And you get? Wonderful. Now, do I just circle this and I'm done? Josh?
No.
What do I have to do? You bring down the parentheses. Wonderful. Then what? Josh just needs a lot of encouragement, okay? Then what do you need? Yes. I don't think Josh is dumb. I think Josh needs a lot of encouragement. Then what do? Abigail.
You distribute 1/2.
Good. You could.
Combine like terms.
I would probably combine like terms just so I'm not multiplying so much. Now what do, Rebecca?
Then you multiply everything by 1/2.
Yes, we have to distribute the 1/2. It is so common for you guys just to forget the parentheses and put the 1/2 on the first term. You have to remember to distribute the 1/2 to everything inside those parentheses. So we have 1/2 x squared minus 4x plus 8 plus 7. What is our last and final step, Sam? And how do I do that? Wonderful. And what do you get? Yes. Okay. Any questions on this problem? From what I saw from your sticky notes, this does look better. Yes, Abby.
Why did they use the word expand?
So because you're expanding this outward. I didn't want to say solve here because is this an equation? No. Does it have an equal sign? It's just a what? An expression. It's an expression. So I kind of put the word expand there to clue you in. Oh, right. I need to take that x minus 4 squared and expand it into x minus 4 times x minus 4.
Okay.
Okay? Normally, especially in here, we don't deal with expressions that much. I just know we need practice multiplying. So that's why I did it. Any other questions? Okay.